Hello and welcome back to another video. So here we're going to be looking at finding the nth term of quadratic sequences. So the objective here is to be able to recognise and continue quadratic sequences, and we also need to be able to find the nth term of quadratic sequences. So a quick definition before we get started. So a quadratic sequence is a sequence where there is a constant second difference. So for example, we might have the sequence 2, 7, 16 and 29. So you can see here to get from 2 to 7 we add 5. From 7 to 16, we add 9, and then from 16 to 29, we add 13. So this time, we don't have a common difference, we have a common second difference, because to get from 5 to 9, you add 4, and from 9 to 13, you also add 4. So if we wanted to find the next term in the sequence, this time we would add 17, because 13 plus 4 is 17. So the next term in the sequence would be 46. So here's an example. So here we need to find the next two terms of the following sequences. So if we look at the first one, so to get from 3 to 10, we add 7. From 10 to 21, we add 11. 21 to 36, we add 15. So you can see here that there's a second difference, because to get from 7 to 11, you add 4, and 11 to 15, you also add 4. So the next one, we're going to add 19, and the one after that, we're going to add 23, because 15 plus 4 is 19, and 19 plus 4 is 23. So 36 plus 19 is going to be 55, and 55 plus 23, that's going to be 78. So this next one over here, so we have 1 to 4, which is plus 3, 4 to 9, which is plus 5, and 9 to 16, which is plus 7. So the second difference here is plus 2. So to get the next term, we're going to add 9, because 7 plus 2 is 9. And the term after that, we're going to add 11. So we're going to have 16 plus 9, which is 25, and 25 plus 11 is 36. So the next two terms of this sequence are 25 and 36. So this question here, we need to find the nth term of the following quadratic sequence. So 3, 8, 15 and 24. So there's a bit of a process to this, so I'll walk through this step by step and we'll do a couple more examples so you understand clearly. So the first thing we need to do is work out what the second difference is. So in this example, we're going from 3 to 8, so we're adding 5, 8 to 15, so we're adding 7, 15 to 24, we're adding 9. So you can see that the second difference, because from 5 to 7 and 7 to 9 is plus 2, you can see that this sequence has a second difference of plus 2. So the first step, what we need to do is half the second difference. So all quadratic sequences are of the form an squared plus bn plus c, where a, b and c are the constants to be found. So the first step is to half the second difference, and that gives us the value of a. So we have a equals 2 divided by 2 in this case, because the second difference is 2, and 2 divided by 2 is 1. So that is our value of a. The next step is to draw up a table. So in this table, we have a few things. We have n, we have the sequence. So n represents the first number of terms. So n equals 1 is the first term, n equals 2 is the second term, n equals 3 is the third term, and n equals 4 is the fourth term. And then the sequence itself is going to be 3, 8, 15, and 24. So I've just written down what the sequence is here. So in the next row, we write down an squared. So in this case, because a is 1, that's going to be 1n squared. So for this one, it's going to be 1 times 1 squared, which is 1. Then it's going to be 1 times 2 squared, which is 4. 1 times 3 squared, which is 9. And 1 times 4 squared, which is 16. Then in the next row, we have to subtract the above two rows. So in this case, we're going to do the sequence minus 1n squared. So the first entry, we have 3 take away 1, which is 2. 8 take away 4, which is 4, 15 take away 9, which is 6, and 24 take away 16, which is 8. So the last step is to work out the nth term of this sequence. So we can see that this sequence here is a linear sequence with a common difference of 2. So the nth term of this particular sequence is going to be 2n plus 0, because the 0th term of this sequence is 0. So we put it all together, so we write down an squared, so in this case an squared is 1n squared, plus bn plus c, and the bn plus c is the nth term of the linear sequence, which in this case is plus 2n plus 0, so we can just write this as n squared plus 2n. If you wanted to double check your answer, you could substitute n equals 1, 2, 3 and 4 to show that the first 4 terms are 3, 8, 15 and 24. Here's another example. So we're finding the nth term of this following quadratic sequence. So the first thing is to work out what the second difference is. So 2 to 9, that's plus 7. 9 to 20, that's plus 11. 20 to 35, that's plus 15. And then we can see that the second difference, 7 to 11, is plus 4, and 11 to 15 is also plus 4. So the first thing we need to do is half the second difference to find out what A is. So A is going to be 4 divided by 2, which is 2. And then we draw up the table. So in the first row, we put n, so n is the first term, second term, third term, and fourth term. And then we write out the sequence, so the sequence is 2, 9, 20, and 35. And then we do an squared, so in this case, an squared is 2n squared. So the first one is going to be 2 times 1 squared, which is 2. 2 times 2 squared, which is 4. 2 times 3 squared, which is 18. 2 times 2 squared is not 4, 2 times 2 squared is 8. 2 times 3 squared is 18. 2 times 4 squared is 32. So the next row we subtract the above two rows, so it's sequence minus 2n squared. So 2 take away 2 is 0, 9 take away 8 is 1, 20 take away 18 is 2, and 35 take away 32 is 3. And the last thing we need to do is work out the nth term of this linear sequence. So in this case, it has a common difference of 1, so it's 1n, and then the 0th term of this sequence is going to be minus 1. So 1n minus 1. So putting the answer together, we have an squared, so 2n squared, and then plus 1n minus 1. This one, we need to find the nth term of this quadratic sequence. So the first thing we need to do is work out what the second difference is. So 5 to 8, we're plussing 3. 8 to 9, we're plussing 1. 9 to 8, we're minusing 1. So 3 to 1, we minus 2. And 1 to minus 1, we also minus 2. So this one has a second difference of minus 2. So now we're going to work out what A is. So A is going to be minus 2 divided by 2, which is minus 1. So that's the value of A. And then we draw up the table. So we're going to have n, which is 1, 2, 3, and 4. We're going to have the sequence, which is the sequence itself, so 5, 8, 9, 8. And then we have an squared, which in this case is minus 1n squared. So if we replace n with 1, 2, 3, and 4, we get minus 1, minus 4, minus 9, and minus 16. And then we do the sequence minus 1n squared. So we're going to do sequence minus 1n squared because we subtract the above two rows. So 5 minus 1, that's 6. 8 minus 4 is 8 plus 4, which is 12. 9 minus 9 is 9 plus 9, which is 18. 8 minus 16 is 8 plus 16, which is 24. And then we work out the nth term of this sequence. So we're adding 6 each time. The 0th term is 0. So the nth term of this one is 6n plus 0. So putting everything together, we end up with minus 1n squared plus 6n plus 0. Or we could just write this as minus n squared plus 6n. Here's another example. So we're finding the nth term of this quadratic sequence. So firstly, we need to work out what the second difference is. So 4 to 14, we add 10. 14 to 30, we add 16. 30 to 52, we add 22. And then 10 to 16, we plus 6. 16 to 22, we also plus 6. So we're going to start off by halving the second difference. So 6 divided by 2 is 3. And then we draw up our table. So we write in n, so n is 1, 2, 3, and 4, and then we write out the sequence, which is 4, 14, 30, and 52, and then we do an squared, which in this case is 3n squared, so 3 times 1 squared is 3, 3 times 2 squared is 12, 3 times 3 squared is 27, and 3 times 4 squared is 48. And then we subtract the above two rows, so we're doing the sequence minus 3n squared. So in this case, we get 1, 2, 3, and 4. And then we finish by working out the nth term of this sequence. So this sequence has an nth term of 1n plus 0, because the common difference is 1 and the 0th term is 0. So putting it all together, we have an squared, so 3n squared plus 1n plus 0. Or we could just write this as 3n squared plus n. So here are some quick fire practice questions on this topic. So we need to find the nth term of the following quadratic sequences. So pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so here are the answers to these questions. Well done if you managed to have a go at those. And yeah, that's everything for this video on quadratic sequences. So well done if you managed all of that. If you enjoyed this, feel free to have a look at other videos in the series of videos on algebra. But otherwise, again, I'll see you again in another video. Bye!